Today we're going to talk about the properties of logarithms. Now, the properties of logarithms may seem like they're just silly math rules that some mathematician came up with and just thought it was fun. But the properties of logarithms actually are very useful when it comes to solving problems with logs. So whether that's trying to solve for x or whether one day in calculus you're trying to take the derivative or an integral, these properties are very helpful and often simplify our lives a whole lot. So there's three main properties you need to know. And the first one is that if you have the log of two things being multiplied together, you see m times n, then you can separate it into two logs and write it as log of m plus log of n. So multiplication inside of a log can be changed to addition outside of two logs. And one other thing I want to say about these properties, these things can go both ways. So we can just as easily take one log with multiplication, change it into 2 with addition, as we can take 2 with addition and condense it down into 1 with multiplication. So in other words, what I'm saying is that this property can go both directions. Whichever way is helpful to us, we can do it. So in our first example here, we have log base 4 of 7 times 5. So that will give us log base 4 of 7 plus log base 4 of 5. So you can take what's multiplied inside of a log and change it into two logs being added together. So in the second example, log of 10x, this is the common log, we would have log of 10 plus log of x. Now just one thing I can add here, if you remember the common log, the one where we don't bother writing the base, is an understood base of 10. And if these two numbers match, that's just going to cancel out. So you could actually just write this one as 1 plus log of x. So that's the first property. It's called the product rule. It allows you to change multiplication inside one log into addition of two separate logs. Okay, second property you need to know, and that's log of m divided by n equals log of m minus log of n. Okay, if you think about the first rule, this seems to naturally follow. If multiplication changes to addition, then division can change to subtraction. So we have here an example, natural log of 19 minus x. So that can be rewritten as the natural log of 19 minus the natural log of x. We have the natural log of e cubed over 7. We can rewrite that as the natural log of e cubed minus the natural log of 7. Again, if you notice, there's something that will cancel out here. Natural log of e cancels out, and you could just leave it with 3. So we get 3 minus the natural log of 7. Remember, these things can go both directions. So we could start with division and move to subtraction, or start with subtraction and condense it back down to division. Both ways will work. Also, this works with all types of logs. Common log, natural log, log base 5, log base 7, log base 3, anything. So any log, these properties are good for. Okay, the third property has to do with exponents. It says log of m raised to the a equals a times log of m. So what they're saying you're allowed to do is take an exponent and move it down as a coefficient. And that's what happened here. So if we have log base 3 of x squared, we can take this squared and move it down front and call this 2 times log base 3 of x. Okay, or this one, log base 7 of the square root of x. You may say, well, that doesn't have an exponent. Well, it doesn't the way it's written right now, but I can write square root of x as x to the 1/2. And you can take that 1/2 then and move it out front, and you'll have 1/2 times the log of x. Log base 7, excuse me. Don't forget to add the base if it's there. Okay, now one thing I want to show you is that this is somewhat just an extension of the original rule, which was that multiplication changes to addition. This is just kind of an aside. You don't necessarily have to know this or remember this, but if you think about this example right here, this could be written as log base 3 of x times x, because that's what x squared means, x times itself. And we know we're allowed to change multiplication into addition. Well, if you have log plus x plus log of x, then you could write it as 2 log of x. So hopefully you can see how this is very closely related to the first property, which is the product rule. Alright, so like I said, you can go both directions with these. You can expand, which is what we were doing, or you can condense, which we'll look at in just a second. So let's start by expanding. Now when you are asked to expand something using the properties, the first thing I would focus on is the product and the quotient rule. In other words, wherever I'm multiplying, split it up as addition. Wherever I'm dividing, split it up as subtraction. So here I would start by saying log base 3 of x squared plus log base 3. And I'm going to go ahead and rewrite the square root of y as y to the 1/2. So that's the first thing we need to do. We need to change multiplication to addition and division to subtraction. The second step is to do the third property, which has to do with the exponents. And that's allowing us to take the exponents and move them down front like this. And that would be our final answer. That is completely expanded. So remember, this is equivalent to what we started with. It's just two different ways of writing it. And I would suggest, again, that you do these in 2 steps so that you don't get yourself confused or do things you're not allowed to do. So the first step I would do on this next one is take care of the multiplication and the division. So I could do log of x to the 1/3, just changing the cube root to 1/3, minus log of 36 minus log of y squared. Alright, now this is something that confuses a lot of people. They're thinking, well, wait a minute, no, you're doing 36 times y squared, so that should be a plus in between. Depends on how you look at it. You are multiplying inside the denominator, so one thing you could do is write parentheses right here, and then you would have a plus inside. Because you're dividing the whole thing, so you have to have a subtraction in front of the whole thing, but inside that division you are multiplying those two together. So that's one way to write it, but I really don't think that's the easiest way to do it. So what I would recommend is you just remember it this way. If it's on top, it's going to get a plus. If it's on the bottom, it's going to get a minus. So since x to the 1/3 was on top, it was positive. Since 36 was on the bottom, it's negative. Since y squared is on the bottom, it's negative. Now the second step to this is to take the exponents and move them down as coefficients. So we get 1/3 log of x. There's no exponent here, so we just leave it alone. And we move the 2 down front and we get 2 log y. Okay, final example. Natural log. Oh, I'm sorry, I shouldn't have changed those to logs. They were natural logs. These properties do work for all logs, but you can't just arbitrarily change them. That was just a oversight on my part. There we go. Okay, so make sure whatever kind of log you start with, that's what you stick with. So remember, 2 steps. Start by dealing with the division and the multiplication. So I would write natural log of x cubed minus natural log of z squared minus natural log of a to the 1/2, or square root of a. Again, if it's on the bottom, make it minus. Second step, should be final step, is to move all the exponents down as coefficients. And this is equivalent to this. So that's how you expand logarithms using the properties. Okay, now we need to condense, so we're going the opposite direction. So whenever you're doing something in the opposite direction, you need to do it in the opposite order. So I would still do this in 2 steps, but I would do it in the opposite order I did the other one. So here what I would do is I would take care of that third property first, as far as moving coefficients back up as exponents. So my first step I would do is rewrite this as log of x raised to the 1/2 plus log of x minus 1 raised to the 4th. So I'm doing things in reverse order this time, because I'm trying to basically go in the reverse as I'm condensing instead of expanding. So I take all the coefficients I have and move them up as exponents. And then I can do all the division and multiplication part. I change my addition to multiplication, my subtraction to division. So I get log of x to the 1/2, or square root of x, times x minus 1 to the 4th. Then for this example, we have 3 natural log of x minus natural log of 2 minus 4 natural log of y. I first take the coefficients and move them up as exponents, and then I take the the coefficient formula of an exponent. So I've got natural log of x cubed minus natural log of 2 minus natural log of y to the fourth. Now I need to change all my my addition to multiplication and my subtraction to division. So I'm going to get the natural log of, on top I'll have x cubed, on the bottom I'll have 2 times y to the fourth, because the subtraction tells me I'm dividing both the 2 and the y to the fourth. So they both go on the bottom. So just as whatever's on the bottom got a minus, whatever has a minus goes on the bottom. Final example, right here in green. Remember to do it in the opposite order we did before. So take care of the coefficients first. Move them up. Log base 5 of x to the fourth minus log base 5 of 6 squared plus log base 5 of y to the 1/2. Okay, remember, anything that's positive goes on top, anything that's negative goes on the bottom. So we will have log base 5 of, on top, we'll have x to the fourth and y to the 1/2, where you can write that as the square root of y. On the bottom, we'll have 6 squared, which you could also just write as 36. That would be our final answer. So when they're asking you to expand and condense, I would encourage you to do it in 2 steps like I've been doing here, and make sure you do it in the correct order.